How's it going, everyone? Welcome to another video, Redux Fundamentals. This is part of the Advanced Redux course that is also taught by Steve Kinney. In this video, we're gonna just exploring is the fundamental of Redux as a way to now not only look at the overview of the Redux, what is the problem that Redux solves, but also is to have a more hands-on approach when it comes to now create our own Redux. So we can now understand what the Redux RTK actually solve, but in a more practical sense, because we know what are the things that is doing, what are the problems that Redux RTK actually solve, which is reduce all of the boilerplate needed, especially when you want to make your state updates maintainable. All right, and some of the best practice that now Redux actually promote, as well as how you can now make it work with TypeScript, which is not a trivial thing, especially if you're using Redux, which is a JavaScript state management. And the problem that now Redux solve is that we can, is how you can now is manage your state updates for client-side and backend applications, right? Or server-side applications. So this is the problem that Redux actually solve. And because of that, and then we dive deep into the Redux RTK, which is now this next step, this evolutionary step of Redux. We need to understand is first is the fundamental of Redux by looking is at this particular course and be able to understand how can we create a Redux from scratch, okay, and what are the philosophy behind that, as a way to describe this, which is something that there is a very interesting article wrote by Mark Deff. As a way to talk now is the as a way to now understand, is this one context and Redux? No, it's not. Mark, wait, what if I want to actually take a look at the Mark, read the Tao of Redux, okay? As a way to now understand is what are the things that actually Redux solve, especially Redux toolkit. All right, what are the goals, something like this. So what is the influence and the goals, as well as the design principles and intent, right? So I think this as a way to recap, how do we get here? All right, let's first to talk about this boring stuff, and then we have now a more practical coding experience into the video, which is, remember that at the end of the day, we want us to now have a state management predictable and easy to work with, because we want us to now not only hold the state of their applications on the server, but also in the backend. Why is this? Because top tech company now realize that since the evolution of end devices like the mobile and laptop and tablets actually are much more performant, so you can now delegate all of this heavy tasks that you do on the server to the client. Why is that? As a way to improve the interactivity. So what does it mean is, by now letting the JavaScript runs on the client side, most of the JavaScript run on the client side, all right, as well as managing the state of the application, So for example, if you are building as an e-commerce, you want to manage the state not only on the server but also on the client, right? So for example, for orders or for orders, transaction history, as well as your profile, right? And because of that, and the end goal of this is to provide a better user experience, so that will drive much more user conversion, the user retention, and therefore user conversion, that eventually leads to more sales, which one of the reasons why we are pushing everything, or why this top tech company actually pushing everything to this particular frameworks. For example, React and Angular, right? And because of that, we need to find a way of how we can manage that state in a maintainable way, so people like Abraham Damoff Abraham, the creator of Redux, it say, hey, well, because at the end of the day, this is what we need to manage this state in a to manage this state. And in order to manage this state, we need to make the state mutations predictable, okay? And the way to do that is by taking inspiration from this Flux architecture, all right? Where instead of actually having one single piece of data, we're gonna have one single store with made of all of this state, okay? And because we want to also make this tool debuggable and testable, we need to set some sort of constraints to that, and that is immutability and serializability, serializability, right? That allow us to now provide is a way of how from the developer experience we can debug our applications much more easy and understand the data flow, as well as the update logic. So when we need to actually is handle side effects, which means for example, input and output operations or anything that changes the state of our applications, for example, network requests, okay? Anytime we want to handle async behavior, we're gonna keep separate from the updating logic, which means that we're gonna make all of these state updates logic synchronous, right? So Redux want all the state update logic to be synchronous, and if you for some reason needs to update that state asynchronous, giving a server response, well, we are going to now use a middleware or use a thunk from that, which is we're going to now make this time independent wrapper around a value, all right? And when we get that data is when we're going to actually do that. So that's the reason why we're having, for example, here is this applied middleware, right? And also is that by having one single root reducer here, we can now is adding all of this slice or all of these reducers, which is all of this update logic, and put as much as update the logic that you need inside of them, so you can now compose all of these update logics, aka reducer, per state, per slice. So this is one of the influence and the goals according to Mark, all right? So because of course he has more experience than I do, and understand that, as well as this is the goals, the influence and the goal, as well as the principles and intent, which means that Redux was built to make state management predict state management or state update maintainable as the main priority. It was built using the Flux architecture implementations. So action history should have now a semantic meaning as a way to you can now debug your application much more useful. It also is introducing some of the fundamental concepts such as purity and immutability, among others. But the idea is that not overwhelm too much the user with that, but slowly get into this concepts, as well as making the update logic testable. All right. So having the ability to now split or modularize is your store by organizing your update logic per slice, per state models, okay? Which means is that, hey, I want to define some updates, for the user. So the user can, for example, is now update their avatar, update their email, their password. If we're talking about now an e-commerce, also the user can update is now or can see at which state is their current or their last purchase, okay? So you can see that in a particular timeline, so we can keep track of that, and any update we receive, we do that and show to the user. All right, so we can have now a separate state from that, and each one of those state or a slice should be organized by having its own reducers or its own update logic per state, okay? And the update logic, of course, must be explicit. So the update logic and the data flow must be explicit, making the Redux API minimal, which is like this, right? Apply middleware, compose, combine reducer, bind action creator, and create a store, okay? So this API should be minimal and extensible. All right, good. So, because we're now looking at this Redux API, the overview, okay? So Redux is very common on React apps, but it doesn't have to, okay? It's important to remember that after all, Redux is this state management library that we can use with any other we can use in any JavaScript environment.
You could build a game with HTML5 canvas and choose to use Redux to manage the state in the application. You could decide, like, I want to use this in an Ember application, and you could use Redux to manage the state in that application. Or Angular. You could use it on the server side in Node. You could also use it just as easily to kind of manage the state using the same principles. So the actual core library itself it's kind of just like unaware of React, right? And then we have those bindings in the either amazingly named or poorly named React Redux library, because on one
binding actions
hand does exactly what it says on the tin. On the other hand, it's kind of like when you explain what something means by using the same principles. Angular. You can use it on the server side in Node. You can also use it just as easily to kind of manage the state using the same principles. So the actual core library itself it's kind of just like unaware of React, right? And then we have those bindings in the either amazingly named or poorly named React Redux library, because on one hand does exactly what it says on the tin. On the other hand, it's kind of like when you explain what something means by using the words. And we'll figure out how to bind it into a React application there. So it's actually not on the surface area of Redux. So the question was, well, why use Redux? Doesn't React these days come with a use reducer that is kind of basically in the Node? You can also use it just as easily to kind of manage the state using the same principles. You could build a game with HTML5 canvas and shoot, if you think about it, because like we said before, like Redux is very commonly used in React applications, but it doesn't have to be. Right? You could build a game with HTML5 canvas and choose to use Redux to manage the state in the application. You could decide, like, I want to use this in an Ember application, and you could use Redux to manage the state in that application. Or Angular. You can use it on the server side in Node. You could also use it just as easily to kind of manage the state using the same principles. So the actual core library itself it's kind of just like unaware of React, right? And then we have those bindings in the either amazingly named or poorly named React Redux library, because it on one hand does exactly what it says on the tin. On the other hand, it's kind of like when you explain what something means by using the words. And we'll figure out how to bind it into a React application there. So it's actually not on the surface area of Redux. So the question was, well, why use Redux? Doesn't React these days come with a use reducer that is kind of basically the same thing? It is similar, but it also lacks a lot of the bells and whistles as well. Right? One way to think about it is like, you might have, a single speed bike that's probably useful for getting around town, but it's maybe not a mountain bike or a racing bike or something along those lines. So one of the things that Redux has that the kind of built-in version to React doesn't have is things like middleware built in, right? Things like the binding for higher order components that will take care of memoization and trying to avoid re-rendering components when possible, right? There's a lot of kind of just slightly more advanced things that come in Redux that are not in the use reducer hook that come in React, and for higher order components that will take care of memoization. React doesn't have is things like middleware built in, or a racing bike or something along those lines. So one of the things that Redux has that the kind of built-in version to React doesn't have is things like middleware built in, right? Things like the binding for higher order components that will take care of memoization and trying to avoid re-rendering components when possible, right? There's a lot of kind of just slight.
Okay. So Redux now can provide you some complex and common use cases like memoization.
More advanced high order components that will take care of memoization and trying to avoid re-rendering components when possible.
Exactly. So Redux now can provide. So Redux can now provide you some complex and common use case for React apps, like memoization, memoization. Exactly. Yep. So Redux now can provide you some complex. So Redux now can provide you some complex and common use case for React apps, like memoization. Okay. Yep. So Redux now can provide you some complex and common use cases for React apps, like memoization as one of them. Okay. Like memoization to prevent re-rendering in React apps, which is useful.
Right, there's a lot of kind of just slightly more advanced things that come in Redux that are not in the use reducer hook that come in React, that in a large enough application, you are either going to find yourself needing Redux, or if you're going down this kind of reducer kind of path, or you might find yourself putting so many plugins into the built-in use reducer hook into React that you've effectively recreated Redux without the same level of support.
Exactly. So you can go is by using reducer from React and slowly realize and slowly adding and extend the functionality of your React app or state management app. Okay. So your React app, state management app, that you will end up creating your own Redux. Exactly.
Cool. Mark.
Yeah, could you briefly describe the difference between Redux and the context API?
Yeah, so the difference between Redux and the context API, so Redux is very similar to this whole use reducer part. The context API is actually used by both of them to kind of thread access to your store throughout the application. So Redux isn't necessarily different than the context API insofar that it uses the context API. The React Redux library that we'll see in a little bit uses the context API to give all of your different components access to your Redux store from anywhere within the application. So both Use Reducer and Redux will use the context API to make your store available without having to thread your props from the highest component down to the lowest level component and your events back up. They both use the context API. So it's not necessarily that Redux is different than the context API, it is using it as well as the Use Reducer hook.
So that's what we are looking at, the Redux here. Okay. For different purpose. It's a transport mechanism. Okay, when they talk about dependency injection, it's a transport mechanism. It doesn't manage anything. Any state management is done by you and your code, typically via use state and reducer. This context is a dependency. Yeah, context is a dependency injection. It's a form of dependency injection because it's a mechanism to transport. It's a transport mechanism because at the end of the day, you want us to now make this data, pass this data to distinct components. So it is a transfer mechanism. Are context and use reducer a replacement for Redux? Not at all. They have some similarities and overlap, but the major difference is that there is their capability. When should I use context? Anytime you have some value that you want to make accessible to a portion of your React component, without passing the value down the tree. So when should I use a context and use reducer? When you have a moderate, the whole point of this context and use reducer is that the more inputs a particular state needs to React, the more it makes sense to have not only a reducer, and if those states needs to be shared across multiple components, distinct components, so it makes sense to encapsulate that in a context with the use reducer. When should I use reducer instead? It's most useful when you have a large amount of application state that is needed. The app state is updated frequently over time. The logic to update that state may be complex. The app has medium or large size code base and might be work on many people. You want to be able to understand when, why, and how the state in your application has updated and visualize the change to your state over time. You need more powerful capability for managing side effects, persistent, and data serialization. So even though I will go with Redux. Yeah, for small applications, no, not at all. But as the application grows from mid to large size code bases, of course, you're gonna use that. That's very interesting here. Okay, the difference between context, exactly, difference between context and Redux. Okay. Right. Context is a form of dependency injection. In other words, a transport mechanism. Holy moly. Yeah. Pretty much like a subway or a car, airplane, the heavy falcon, right? It's a transport mechanism. It doesn't manage anything. Exactly. It doesn't manage anything. Any state management is done by you and your own code. Okay. Yeah, it makes sense. Dependency injection. Anytime we hear about the word dependency injection, it's just a fancy word to say a transport mechanism. A data transport mechanism. Or a state is a form of dependency injection. Okay. It is a transport mechanism. It is a transport mechanism. Makes sense. You want to now pass this data to this, to that, to other different models and that kind of thing. Holy moly. That's one of the reasons why I'm looking at this. As a way to make sense of all of this. Oh my god. Whew, that's quite interesting. All right. So,
With that,
let's get into this. Okay. Okay. Okay.
with that,
Okay. Redux APIs and Compose. So we're starting now to look at the anatomy of this. Redux without React, right? Which is the anatomy of Redux. Redux API and Compose. Redux API, APIs and Compose. Makes a lot of sense. Okay. Redux APIs, because there are several APIs. So please, APIs and Compose. Followed by the Redux store and Reducer. So Redux, okay, Redux store and Reducer, Redux store and Reducers.
let's get into playing around with some of the API
Reducers.
of Redux. We're going to go through pretty much.
Redux store and Reducer, Redux store and Dispatch, Redux store and Reducers, and Redux stores and Dispatch, which is something that I'm quite familiar with. And then Actions Creator, setting initial state. So actions creators, right? Actions creators. Okay, actions creator and setting initial state. Setting initial state. Okay. Some rules for reducers. And subscribing and binding actions created. Exactly, some rules for so rules for reducers. Okay. Subscribing and binding actions. Subscribing and binding actions, which is, again, what we're going to do is just to write from the scratch our own Redux. Combine reducer and enhancers. Combine reducers, enhancers, okay, and middlewares. Okay, enhancers exercise, middleware, right? And middleware exercise. Okay. Interesting. So let's get into this.
Much each of these. Now, there's a little bit of a lie in here, which is Redux itself has 5 methods or functions attached to it, but creates a store object that has 4 more. right? So technically it's got 5. I wasn't lying, but if we're being intellectually honest, there might be a grand total of 9. That is the entire API surface area of Redux, and we're going to pretty much master the library itself, and then we will kind of tie it in to building some React applications. Cool. All right. So we've got a few in here. We've got create store. We've got compose.
So we're going to master the Redux API in itself. And then add some useful things along the way.
We've got bind action creators. We've got apply middleware. Let's start out with a good little helper library over here called compose, right? And compose is a function that is not dissimilar to if you've ever seen like pipe or flow or something along those lines. Compose actually has nothing to do with Redux per se. It's just attached to the Redux object because you might need it for things. What things? Well, there's a little like, I gotta keep you, there's a cliffhanger, so you tune into the next episode. But basically what compose does, there's a cliffhanger, so you tune into the next episode. But basically what compose does is allows you to take a set of functions and create one function that will pass a value through each of them. Let's actually see what that means. Let's make some functions together. We can make one here called make louder. These will all just take a string, all right? And so we'll say string to lowercase string. We'll say make louder equals a string, and then we will string to uppercase, right? Let's give ourselves a little more room here. So we don't need that much.
So compose.
All right. So we've got make louder.
Allows you.
We've got const. Let's say repeat 3 times.
No, it's like allow you.
That'll take a string.
Right.
And it'll also do string.
Functions.
Repeat 3. I bet you didn't know that was a method on string objects. And then here's another fun one that is not even HTML semantically valid anymore, but we're into it. Is embolden, which will take string, and then we will string dot bold.
So pretty much this is
which will wrap it in B tags.
Right. Function composition.
So what? Just before we look at compose at all, if I wanted to make a function that took the value and effectively made it uppercase, then repeated it 3 times, and then wrapped it in those bold tags, what would I do? Any guesses?
I said make.
You will have to create a high order functions for each one of them.
Over the function and apply them one by one.
Yeah, I can map over the functions and apply them one by one, right? And so I could create an array of all 3, and I could take whatever the value, and I could use reduce or I could use map and run it through all 3. I could even I could make a function called, let's say, const repeat 3 times, make louder. Let's say, yell, make louder, repeat.
Okay, make louder, repeat 3 times. Okay. So here we're gonna create some functions here as a way to say, hey, make louder, we'll fork this sandbox. Okay. Make louder
3 times.
Okay. And string uppercase repeat and bold. All right. So make louder, you're gonna take this string and then you're gonna say, hey, string to uppercase, right? To uppercase, right? And another function here, which is repeat 3 times. So repeat 3 times, right? Which will be a string, and I want you to now do is the string dot repeat 3 times, right? Number of copy to append. Okay, so I want you to repeat these strings next to another, and then the embold, const, which is embolden, embolden. All right, where here you take the string and you pass that using now this convention from JavaScript as a way to, instead of actually having for us to write all of this ceremony, which is the function, the body of the, which is the function keyword, and then the parentheses passing the arguments, and then the curly braces for the body, and then define the line of code. So all of this has been optimized to actually thanks to the TC commit and the JavaScript spec developers to write our code much more succinct, which is a great thing, right? So we say, hey, string dot bold, exactly, bold for that, right? Okay.
Embolden. Right? That could take a string, and it could take the array and reduce it on through, right? We could write that, and that's effectively, spoiler alert, what composes it's basically doing under the hood for us, just making us not do that. It could also, like, we can say make louder on the string, and then we can immediately pass the value of that into repeat 3 times,
Exactly.
and then with that we can embolden it. Right? And now we say console log,
Is compose.
and we'll say like hello. All right? You can kind of see it down here in the lower right corner. It works. Now, we can see a world where like doing this all the time isn't great, and this is what compose gives for us. So all we can do in this case is say compose.
So as you can see here, you can define as another function, which is make louder, repeat 3 times, and then bold. Make louder, repeat 3 times, and embolden, right? So what the thing you can do here is like now calling this function. All right, by calling here, you say, hey, first I want you to call this function here. Exactly. I want you to now. Yeah, it's like call this function. In this case, with a string, right? So it means that we need to create this as a function. We're gonna pass this value to the make louder, and the output of that will be is now the repeat 3 times, and the output of that will be now is the embolden, right? Embolden. So if we can now console log this, right? We say, hey, make louder, repeat 3 times. When we save this, I want to take a look at the console here. I want to take a look at the console here. Oh, for real? Because I'm running this on Firefox. Oh, I don't believe you. I don't believe you. How this can happen? I don't believe you. Okay. This has to be okay, so this has to be on Chrome. Okay. Yeah, this has to be on Chrome. And if you want to take a look at the console here, yeah, of course. Alright. Well, in the case, no problem. Let me actually create now a new one to actually is capture the Chrome, Google Chrome here. There you got it. That's right. Make sure to disable the other. All right. So you can now not see me. Hey, hello. I'm gonna put this below and disable this. Activate this one. All right, and now that'll work as expected. Good. So hello there. There you go. Okay. Cool. So now we were able to actually when we run this code here. Question: is this actually running this? Nope. What if I want to take a look at the terminal? If I want to take a look at the terminal, output ports. Problem. What the French toast is this? Okay. Yeah, because we're passing. Okay, it actually worked. Okay, we are now passing is here the reference. But I want to. What? This file is read only. For real. So is this one? Oh, grab. Okay. And then I pass some string here, say hello. And then I reload this. I will get this printed out as expected, right? If we take a look now, this is here, right? So far so good. So this is what actually is now this compose. Instead of us having to do that composition or that compose of functions, this function actually does that for us. That's quite interesting. Compose in Redux. That's why all of these particular concepts here are very powerful in use. Interesting. Compose functions. So, all right. Remember that at the end of the day, what we want to do is to update our state. Okay? We want to make the state update manageable and maintainable.
Right. And now we say console log. See
So
world.
instead of actually doing that, we can only just pass is that. All right. So so with Reducer, so with Redux, so with Redux, we can say is that, hey, I want you to now make this, make Laravel then compose by now calling the compose and now passing this series of functions that I want to execute. From the first and the second in this order, right? So we say, hey, make louder. Okay. The question is, how are we gonna pass this? Because we need to pass is the reference, and how this is actually works behind the scenes. Okay. Well, luckily for us, in the documentation it say, hey, you are going to pass is the argument, which is the function to compose, and the section is the rightmost argument, which can accept multiple parameters. It will provide the signature of the resulting compose function. So it's actually not that quite eloquent for that. So the last,
Right, I get the same result down there. It's a way to take multiple functions and compose a new function out of all those pieces, right?
I make this composition repeat 3 times, as well as go embolden. Okay, and then now call that as is, right? So when you say now is make louder with compose. Cool. So if we now refresh this, reload this, we're gonna see that outcome repeat twice. There you got it. Be hello, and be hello, which is quite interesting. It's not doing the same thing as we expected.
And that is one of the helper methods that comes with Redux, which means for those of you sports fans who are keeping track at home, we are now 20% of the way through the entire surface area of Redux, and one of them was just a functional helper in this case.
Mm-hmm.
All right, let's take a look at.
That's quite interesting. When I use the compose, look at this, make louder, repeat 3 times, and embolden. Okay. And in this case, the order was different, which means that the last function they're gonna pass, what they're gonna pass is this pair wrappers, which means that the first I wanna pass is from the bottom. The first I wanna pass is from the bottom to that. What? So it means that it's not the order in which I'm going to pass this. It has a particular order on how it's going to call this function. So in other words, that hey, because I want to now embolden and then repeat 3 times. Okay, and then I want to make it louder. That's actually how is going to create this output that we want, right? That's quite interesting. You know, we get the same output. So here with this compose functions, okay, what it's doing is now calling this. You shouldn't call compose directly. Redux toolkit configure store method automatically configure a Redux store with a standard apply middleware, and Redux DevTool is store enhancer and offer an enhancer argument to pass it additional enhancers. But the thing here is that we're using this compose function that behind the scenes, okay, is now calling this. So it's now calling this. The compose is also enabled as a general, is also usable as a general purpose standalone method. So the function to compose say, hey, each function is expected to set a single parameter. Its return value will be provided. Its return value will be provided as the argument of the to the function standing on the left. Exactly. So it means that this will be so the output or the return value, so the output of the first, so the output of the so the output of that function will be passed as the argument to the next one, to the function on the left. In this case, this, it will pass. So the output of this will be passed to the function to as a function argument, as an argument to this function. So it means that it's going to embolden, then repeat these things 3 times, all right, and now the output of this will be the argument of this function, which is make it louder. That's why this actual thing is working, because it's doing that some sort of composition of some sort of assembly line. Where you have now, hey, the output of this function is going to be the input of this next function, and so on and so on and so forth. This is pretty much like a pipe, which is a concept from Bash. Interesting, but here they call this compose. All right, slowly but progressively, we are now getting exposed to this fundamental of this functional programming.
Let's take a look at the main event here. The other ones we'll see as well. You can guess what apply middleware does. We'll see. We need some action creators before we can bind some action creators, so on and so forth. What we'll do at this point is, what if we went ahead and let's go ahead and make a store. So I'll go ahead and I will say const store equals create store. And I will just warn you right now, this isn't going to go well. Luckily for us, if you look over on the right, the answer there is pretty good, right? Or at least the error message is pretty good, which is expected the reducer to be a function. Right, and so we can kind of see in here, we hit create store, we can go ahead and we can see that it's expecting a reducer as the first argument. It'll also take some other arguments as well. It's pretty flexible with what it takes. There's only one real requirement that it takes a reducer. Now, I had some questions about use reducer before, so can anyone give me the kind of high level of what a reducer is?
Stop getting and stop here.
That was okay. It's a function that takes an state. It's a function that takes an state. It's a function that takes an state and an action to generate a new bit of states.
Comes out.
All right, I think that's actually wildly good to work with. So pure function, stuff comes in, stuff comes out. Actually, that works really great. Really, two things go in and one thing comes out. And so while reducers seem okay, we gave something a fancy name, that doesn't necessarily mean that it is complicated. The kind of high level of what a reducer does is a function where two things go in, state of the world, so a JavaScript object that represent everything that's happening in your application, right? All the kind of important stuff, whether or not a modal is open or closed, maybe not, but any kind of the actual model state of your application is in one giant JavaScript object. And then occasionally things happen. Users click buttons, network requests come back, all different things go on. They change routes within the application, so on and so forth. Things happen, so you take the state of the world, which is a JavaScript object, you take a thing that happened, which is a JavaScript object, and they both go in there together. And only one thing comes out, a new state of the world, right? So if you take everything that's happening and you add whatever new event just went down, how does that affect the state of our application? The answer is not at all, right? We'll see a new to-do coming on the to-do list doesn't change the current user. Okay, so then we return the same user, so on and so forth. But generally speaking, there are different things that happen as events happen in our application. We want to figure out what that actually means. So all it is a function that takes two arguments. It will take state, an action, and it will spit out a new state. Right? And it's just a plain old JavaScript function. So let's go back to kind of our code example before, and we could make one inline, but we could also theoretically just make the world's simplest reducer. And by the world's simplest, I mean a reducer that kind of barely does anything. So we'll say a reducer, and like I said before, it takes the state of the world as the first argument. And we'll come up with some initial state that we'll use in a second. So we'll say initial state equals value is 0. And it'll take some action, and all it's going to do immediately is going to return that state back out. Which, what we're basically saying here is, okay, no matter what happens, nothing changes. Which is a little pessimistic, but it's fine. We'll improve upon that. We'll make some change in the world in a little bit. So this is a reducer, and if we clear out the sidebar over here, which has been reloading for me a bunch of times, you can see I can even console log the store. And you see we're not getting that error anymore because we gave it a reducer. Now, it itself has 4 different methods as well, and we'll kind of talk.
Okay, so when you create this store, is that, right? This is just as a way to see how this now store actually is. Okay, so far so good. So let's now create a store, shall we? Okay, so that is create store. So store of the create store, right? But it says that it needs an reducer, and a reducer is just a fancy function. It's a fancy way of a function. Okay, it's a fancy way. Okay, it's a fancy way to say, hey, this is a reducer that takes an action and a state, and then generate a new bit of a state out of that, right? Pretty much like it takes in this case exactly it takes first an state and then an actions and then generate a new bit of state based on that action, right? You can say, hey, return is now this state. Cool. And then we need to define is what action might be, or the initial value here in this case. So the initial value, where this state will be what, a counter, okay, but the value will be a 0. And then we say, hey, this is our reducer. We're gonna pass now a reducer for that. So if we save this and we actually refresh that, so you can see the change. The store says, great that you passed me now this particularly update logic, okay? And then I'm going to now generate is some other common functionality and useful functionality around that. So we can say here is, hey, console log is the store. Makes a lot of sense. So I'm gonna create some convenient functionality for you. The dispatch, get states, and all of that kind of thing. Okay. So let's now create a store, shall we? So is this. So is this. All right. Okay.
Talk about some of those in a second. Does anyone want to take a wild guess what replace reducer does?
Replace reducer. That's interesting. Symbol observable. All right. So this actually instead, in fact, it returns you this one, right? And followed by the prototype. Because this is JavaScript. Right? So is this one. Very, very, very interesting. So our store create now compelling methods to remember, make the state management, or to make the state management maintainable by making states update maintainable. Okay, that's the story around this.
I'm gonna take a wild guess and say.
So you're gonna take a long guess here to replace reducer. Take a reducer and replace reducer. You think of replace another reducer?
That it replaces the current reducer.
Tell him what he's won. Yeah, all it does is that function you passed in, replace reducer takes one argument, which is a new reducer, and it swaps it out. Why would you ever want to do this? Yeah, what replace reducer does?
I'm going to take a wild guess and say that it replaces the current reducer.
Yeah, that is replace the current reducer.
Tell him what he's won. Yeah, all it does is that function you passed in, replace reducer takes one argument, which is a new reducer, and it swaps it out. Why would you ever want to do this? You know, when
Is it used for code splitting?
Exactly.
Oh, this is using for code splitting. So you want to wait? What a second. So you want to use a reducer? Okay. This replace reducer. You want to? Oh crap. Okay. You want now to use this reducer here. You want to replace the current reducer. So you want to replace the current reducer with a new one, the current update logic with a new one, the current update logic with a new one. And if you want to update the current update logic with a new one, in this update logic, okay, this is used for code splitting.
Exactly, it's used for code splitting. Later on, we saw that
So the replace reducer, which replace the current reducer with a new one, yeah, with a new one. Why we want to do that? Why we want to update the, why we want to replace the current update logic with a new update logic for code splitting. Code splitting is one of the reasons. So if you replace this update logic with update logic, and when you want to now code splitting or chunk all of this application into smaller bundles,
one of the helpers that we didn't pull in here just yet was combine reducers, right? Because you can imagine a world where having one function that controls all the updates to say your applications is not going to scale, right? So combine reducers allows you to kind of split it out into smaller reducers that it then combines. We'll see it in a little bit. But you can see a world where you might have only the initial reducers that you need that you combined into what you give to Redux. And then later on, as they load in more code through code splitting, you would just simply swap out the reducer with one that has the additional reducers combined into it, right? So all it does is it takes one reducer and swaps it out for another one. So now we're even 25% of the way through on the store, and we'll see some of these in practice. But let's go for a bonus round real quick, which is what do we think get state does?
You get the state?
Yeah, get the state, right? You have a store, it holds the entire state of your application. Occasionally you're going to need it to determine what should be passed to components, right? So let's, we'll take a look at some of that as well. We need to talk a little bit about what an action is, right? Because one of the things that makes this whole reducer pattern a little bit different is it's not just like we call methods on the store object and it changes stuff, right? We saw in the reducer, the state of the world goes in, the action goes in. Well, how do we tell the store, hey, here's an action. Go into the reducer and figure out what you should do about it, right? That's going to be that dispatch function. So let's go ahead and we'll just make a action real quick. And we'll actually call this one not, just for our own clarity, we'll call it increment action. And
you follow this convention
great.
For that?
This is all that you need for an action. There's only one requirement for actions. That one requirement is that it has a type. Because if you're going to say that something happened and you're going to ask the reducer to see if the world should change, it's only polite to tell Redux like what type of thing just happened, rather than be like, yeah, something happened. That's not particularly fun. So the only requirement is that there is a type. Now, after that, it is up to you what you want to put on the rest of that object. However, you can imagine a world where if everyone on your team does whatever you want, like it puts whatever on an object, you will all slowly learn to hate each other, right? So there are a bunch of ways to handle this. There is one, the pattern that we use at Twilio is what's called Flux standard actions. Because Redux is based on Flux, the history lesson is not important, but it's basically just an agreed upon set of properties to put on an action. Again, but only if you need them. Like the only thing that Redux requires is that you have a type. The other things that you might see is a payload. The pattern that we use at Twilio is what's called Flux standard actions.
So, okay. Redux in the store dispatch. Code splitting is one of the reasons.
Redux is based on Flux, the history lesson is not important, but it's basically just an agreed upon set of properties to put on an action. Again, but only if you need them. Like the only thing that Redux requires is that you have a type. The other things that you might see is a payload. And a payload can be an object, or it could be, like in this case, we're going to increment by 5 every time. The payload could be 5. But if there's more than one thing that you need, you can use a JavaScript object as well. So it could be a JavaScript object with many properties. So if you were saying, like, OK, I want to add this to do to that user, you're probably going to need to tell the reducer what to do and what user. But if it's just increment, you can say 5. The other one is meta, which is just kind of any other information about the action. And then there could be possibly an error property if there was some kind of error that you need to know about. Right? For the majority of this workshop, we're going to worry about type and payload. Right? Those are the two things that we predominantly care about. And we'll use as this goes along. Right now, we're only going to stick with the type.
That's very, very interesting. Take a look at this code pen. Okay, so this is the exercise, right? Okay, makes a lot of sense. So it's creating all of this
There is
functionality for
a
us.
few things that come up around this, which is, why did I have to scream the word increment? Right? It's not because I feel very passionately about incrementing
Why do you
a
ha- why do
value.
you
I mean, I
have to
personally
scream
do,
this
but that's not the
instead of
reason why I
because
typed it
you're
all in capital
passionate
letters.
about it?
Does anyone have any hypotheses on why we, by convention, use all capital letters for our action
const?
types?
I have a question because if you use Redux Toolkit and create slice, the actions are not all uppercase, right?
Yep, that is a great point that we will talk about in a second. They don't have to be all uppercase. It's just a convention, and we'll talk about why we tend to use. We're going to use the all uppercase at the beginning, and then we're going to swap to a different syntax towards the end for a reason that we will get to probably in the next 30 or so seconds. Any other guesses?
So maybe this type is some kind of constant.
Yep.
So that's why.
Yep. So basically, one of the things that was just brought up is that, well, when we use Redux Toolkit later, Redux Toolkit might do something like this. The action type might be something along the lines of counter/increment, right? That totally works. It really can be any string. The convention a lot of times is to use a string and to use a constant, right? To reference that string. The reason for that is, let's say hypothetically, we want to say if action type.
So the dispatch is just a function that will notify the reducer, the update logic, to trigger it based on a input, which can be human or which can be human or computer. Okay. So the convention, the convention here is this. So now the convention here, so the conventions from the flux action types is this. Okay. And now create actions, right? And now create actions, which is so we can see what a reducer is, as well as an action. So here, followed by the action, right? This is the action, and it is convention, right? So we follow now this action, which is just a simple object that is the type. Okay. The question is that this action, this action type here that we're looking, this action flux convention types, all right, flux standard actions like this, right? So flux action convention here. All right. Makes sense. And then as we move on, as you can see, is this actions must have a plain JavaScript object and a type. An action may have an error, payload, and meta. Very, very interesting. Very few people actually know this kind of thing. Remove looking from maintainer. The last year. Okay. Redux utilities. Traveling around open source, former organized at Hanover, yes. Okay. Jesus, French, those guys were. Hanover, Germany. Okay. Very, very interesting. And I get it, man. Interesting. And of course, all of those people are actually. Copy server data. Interesting. Interesting. Okay. Okay. Increment. Increment. Right?
Is increment. I almost made my point. Is increment, then we'll say like state.
Then you're gonna
will
extend
return
that.
State, and then that'll be state.value plus 1. Right? And this all works, right? We dispatch an action with the type of increment. It would modify the state and increment it by 1. The problem with using strings everywhere is, you almost saw me do it, which is if I misspell one of those strings, the action of increment will fall through the entire reducer and not hit any of my conditionals. Or if I mistype it in the action, it will fall through and not hit any of the conditionals, right? So a lot of times what we'll find ourselves doing is we'll say increment, and then we'll swap these two out. And now, when you're using the constant everywhere, if you misspell it, you'll get a reference error, right? It'll be like, there is no constant called, whatever. And the reason we're using all capitals is to separate it from the rest of our variables. We saw before we could use that slash. It's just really hard to write a constant that has a slash in it because it's not valid JavaScript. There is nothing stopping you, if you prefer, to write it like that. It doesn't matter, right? The only reason a lot of times we'll match them is so that they look exactly the same, but it's totally like a team preference. If you prefer to use the Redux Toolkit style, you're more than welcome to. If you prefer to have them just match what you see in the code, when we see the developer tools later, like I personally, like I like the Redux Toolkit style. It's just hard to do in a just regular Redux application. And then also when I'm using the developer tools later, I like whatever I see in the developer tools to match whatever I'm using in my code, right? It gets a little crazy when you're using like increment in all capital letters because you have to, and then you have it looking different when you look at the tools and things flow through. Totally a matter of preference. You can use whatever you want.
What's a good reason not to use Redux Toolkit?
So there's a few reasons, right? Like one is if you have an existing code base that is more than a year or two old, right? There's a definite like whether or not it's time to refactor, right? Which is for a library that's been around for 5 or 6 years, like to be clear, most of like the future code bases that we write may or may not use Redux Toolkit, but all the previous ones that predate it definitely don't. The other factor is like Redux Toolkit, the advantage to it is also the disadvantage, right? Advantage is it takes a bunch of common patterns and abstractions and papers over them so you don't have to think about them. But that's like most abstractions, which is if you are doing particularly complicated things, right? You might spend more time fighting the conventions that it hands you to make your life easier than you would kind of just dropping down one level. Good abstractions should help you for most cases, but they have to give you an exit hatch, right? In the cases where they're no longer working for whatever you're trying to do, right? So things where an action might happen throughout many reducers throughout the application.
That's another value here, bro. It's like, So here is that if this reducer now detect here, so if this action, the type is equal to the increment, all right? Now what you're gonna do is to return is the state or plus, for example, right? Or return is a new state of that. Exactly, return is the state, right? Or in this case, the state, which will be the state plus 1. Oh, the state of value. Oh, because you define that as it is.
Right, Redux Toolkit allows.
And otherwise, you want to return is now the state if there is no matching scenario like that, right? Of course, we are assigning. We're not comparing. That's what happened. So this is now the increment action for that.
Allows for that, but you could find yourself spending more time trying to wire that all together than just dropping down a level and getting the kind of pieces that you can snap together yourself. It really, for a lot of things, is a judgment call. We'll actually see that when we get to React Redux. There will be some decisions between hooks and the hierarchical component pattern where there isn't necessarily a right answer. It really depends on like what your priorities are and what the nature of your application are. And I think it's about knowing that you have the choice and knowing what each one brings to the table, and then with you and your team making a decision on how to move forward in that case.
All right. Okay, so if we take a look now at the Chrome thing here, like this, and we now calling it this, we actually see that we are now is in our dispatchers, which is dispatching these actions here. We get the state, it's gonna return, and then we're actually passing is the reducer for that.
The other thing that we will see a lot of times is like this is a pretty simple action type. But as we made more complicated ones, we're like, okay, maybe we need to like take multiple arguments and put.
So that's what we have here, this, for example. Interesting. Okay. Okay. And that is this particular playground. The example. Exactly, not exercise, is example here. Similar for this. Okay. All right.
Put the multiple pieces in the payload, we might find ourselves just using a function to create an action on our behalf. This is also helpful because if this action were to grow, and like later in the workshop we'll see some that even have like a few different properties. Just the more typing, I'm very lazy. The more typing I have to do, the more likely I am to make a typo. That typo could be one where I just don't.
So actions creator recognize that the more typing we need to do, the more likely to make a typo is. Therefore, we need a way to remove that from the table. So any time we need to create more complex actions, and as a way to prevent typos and errors, that's why actions creators are useful. It makes a lot of sense. Completely useful.
See it at first and lose half of my morning. So one of the things that we're able to do is we can a lot of times make a what's called an action creator. And an action creator is a very fancy word for a function. So I could say increment, and that could be mount maybe. It doesn't have to be. We could even say, it could be as simple as
type increment here.
And this might be what I choose to use on my application. If we want to like set a payload, I can say something like amount, and it could do
the payload with the amount.
And we could use the amount. If later that needed to become an object, I could change it as well. One of the reasons why this pattern is so powerful, despite being so simple, is let's say you wrote those objects everywhere. You're like, no, I don't mind. I'll write curly braces, type increment. It's fine. Later on, you want to change a feature. Good luck. You now have to do a search through your code base for every time you wrote that object and go looking at them, change them all by hand. If you want to change the format of your action and use an action creator, you are able to just change that function somewhere, and everywhere that's using it will get the new action type. Right? It's again giving yourself that helper and abstraction to make your life easier, and not necessarily doing it because someone told you have to, but doing it because you want to and you see value in it. Cool. So we saw with increment. We can also make one called add, which will kind of show you the same basic idea. This one will actually take what we had in increment. We'll put it in here. We'll make a new And I can mix and match my action types. I shouldn't, but I can. So we might create action creators for all the different things. So in the reducer itself, right now we just need to deal with any cases that we care about. And again, a shocking amount of Redux is just JavaScript. Right? This is just a function where two objects are going in. So we can go ahead, like here we're looking for the type increment. Here we might say, if we wanted to like base it on a payload, we might say action type is add. And we'll say in this case, state is state.value plus action.payload. Right? So now, based on whether they increment or whether they add, and obviously we could add things like decrement or set and stuff along those lines, we can add stuff in as well. Question?
Okay.
Yeah, the initial state is value and 0, and you always returning like a different output.
Yeah, it should actually be value as the key. This is why you pair program with half a dozen of your closest friends to catch just silly mistakes that.
Okay, that makes a lot of sense. Exactly, it's like, okay, this is value, by the way. So when we reload this, there's a way to see our progress. So now we can see actually is that.
You might come across as you are both talking and typing at the same time. So this is an object that has the same shape here as well.
And then he defined this as so counts like add for example, and here this increment, he called this as counter increment. Makes a lot of sense. Where now you define is this increment action with the type increment. Alright, and also this another function which is like this, add amount, and then you have the type add, and this is now creator, actions creator allow us to avoid repeat ourselves when writing this flux actions conventions. Makes a lot of sense, which means that this is a function that you're going to take some value, let's say amount, okay, and it's going to return now an object here with the shape of, so I want you to evaluate this, which to return is this with the shape of type, which will be is now add followed by a property called payload, which is, let's say, whatever pass you are receiving here from the amount, right? And then not only that, you want us to add that to your reducer and say action.type, hey, I want you to now add this, I want to handle this update logic with these actions, and then return is now this new object here, this value state dot value here plus whatever we're passing is at the action dot payload, right?
Value, and so we're just taking state.value and incrementing.
Okay. Okay. So it means this.
Right, you could break this out as well onto a different line and put it in there. So we could say, again, it is all we saw that we have, the other thing that we will see a lot of we saw that we have a few different methods here. We already explained replace reducer. We've already taken a lucky guess at get state. How anyone wanted, we're down to 2 methods left, dispatch and subscribe. So if you wanted like an easy 100 points, these are like Super Mario Brothers points. They don't actually get you anything, but you can see how many points you can earn. That should have been our demo app now that I think about it, but here we are. Anyone want to take a look between dispatch and subscribe, which one's going to get an action into my reducer?
Is it
Wait, what?
Subscribe, which one's going to get an action now that I think about it, but here we are. Anyone want to take a look between dispatch and subscribe, which one's going to get an action into my reducer? That should have been our demo app now that I think about it, but here we are. Anyone want to take a look between dispatch and subscribe, which one's going to get an action into my reducer?
The dispatch.
Is it dispatch?
Dispatch, all right, 100 points.
Dispatch.
So with that, once we have our store in place, I can go ahead and I can console store, and then we'll say store.dispatch, and I can call that action creator, increment. That will return the object in there. And then just to take store.getState for a spin.
Get state.
Got that in there as well. Can't read value.
Because you didn't define is any value.
Maybe we need to pass initial state.
Yep. This is why, again, so we have 2 options for passing the initial state. So we can't find the value on undefined. That's because the very first time around, we haven't returned anything out of here. We have 2 options for getting the initial state in there. The first option, kind of the older option, is just pass it in here. Right, now you can see my code works. This is kind of the original way to do it. And one of the reasons that the create store supports it is like, that seems like a reasonable place to do it, but also like default arguments weren't standard in the JavaScript spec yet when Redux first came out. So there wasn't an easy way to also do. This will be if state ends up being undefined the first time we call it, then it will set it to the initial state as well. The reason that I like this syntax more is because as you start to split up your reducers all over the place, right, like you can then have the initial state just being for that particular reducer. When we see combined reducers, that'll make a little bit more sense, but it'll allow you to kind of have each piece of initial state per slice of the reducer. I think I saw another hand.
But what if we have multiple properties in the state? Like suddenly we just have value. What if we have more properties?
So the answer, like most things, is it depends. If they are all related, they can all be in the same reducer, right? Like let's say it's an array of tasks, right? Or it might be, are we loading, is there an error, and what's the data? That might belong in a reducer. Generally speaking, when we get to combine reducers, we'll see this. It's better to like split our reducers out to each little common piece. So we might take care of like if we're buying a phone number at Twilio, we might have one that just keeps track of the phone numbers that are currently loaded. We might have another one that keeps track of the current user, right? What we do is like we could put it all in one giant reducer, and we could walk that state and try to manipulate it.
Some tactics here as a way to know how you can state that is to handle this initial value there or passing is here the initial value here. Right? So once you do this, right, and then you pass the initial value to the reducer, you make sure that you always get the initial value per time. Well, okay. So when you now actually is to get the state, exactly, is using now a closure for that, so you can have access to that. It's gonna tell you, hey, if you wanna get access to the store, you wanna, instead of actually is to get value, I think is this, or get state. Okay. If you're gonna get state from that, yeah, you can. All right. You get states where value, of course, is 0, right? You can also is not trigger is a particular reactions there by saying is, hey, store does store dot dispatch with the name of the actions that you want to dispatch, where in your case is the add, let's say to call it is the increment, increment actions, all right, and then we want to get the state out of this, right? That's right, and then we want to get the state out of this. So it means that as we look at this, all right, we already get the value of 1 because we already incremented. So far so good, and this is now the fundamentals of how you can do this. And depend of the use case, you might want to pass the initial state to the reducer itself or to the store as well. So okay,
And we can see that can get a little tricky, right? And this kind of goes into one of my recommendations about reducers. We saw we didn't like initially bring this up, but we saw that if you mutate an object, it's very hard for JavaScript to know that it changed and it's a new value, which makes React very sad. So a lot of times you notice that we didn't just like, plus sign.
Okay, so that'll be all for this video. Take care, bye bye.